terms that we have there. So now here we say step number 3. Step 3 there. So we need to show that a statement. So to show that a statement is also true for n equals to k plus 1. So now what this simply means that if we add the new term to the expression that we have here on the inductive hypothesis term, then on the right hand side where there is n, we're going to substitute with k plus 1. So if we add the new term, it should be equal to the left hand side is supposed to be equal to the right hand side. So meaning that here, if you remember what I said when I was introducing this, I said that our sk plus 1 term here should be equal to sk plus a new term that we're going to add now, which is ak plus 1 there. So we'll talk about this right here when we start doing step number 3 there. So now here, what we're simply just going to do here is we get 1 plus 3 plus 5 plus 7 there plus. So we first write the same way it is here, k 2. So open brackets, we have 2k minus 1 plus a new term now. What is n there? We're going to put k plus 1. So open brackets again, we have 2, open brackets, k plus 1 minus 1 like this being equal to, and this side we have our k plus 1 squared like this. Okay, so now you notice one thing here. This term that we have on the right hand side, this side here, this is the sk plus 1 term that we have there. Okay, so then if you look at starting from the first term there all the way up to this term here, this gives us the sk term. This gives us sk rather than. Then this new term that we have there, this now is our ak plus 1 like this. So it's supposed to be a subscript there, so let me just erase that. Okay, so this is supposed to be a with k plus 1 as a subscript there. So meaning that it should be equal to, if we add these two terms together, it should give us sk plus 1 like this. So this is what I was talking about there. So we're just going to add sk. So for sk we're going to get our k squared, then we get ak plus 1, which is this term here. It should be equal to k plus 1 squared this side here. So let's go ahead and solve that. So here we're going to get our k squared plus open brackets here. So we have 2k plus 2 minus 1, we close there, being equal to k plus 1 squared like this here. So there are two ways we can do this. It's either we can factorize what we have this side here, or we can just go ahead and expand this, then we also expand this, then we compare what's on the right hand side if it's equal to what we have on the left hand side there. So now here we're simply going to say we have our k squared here plus 2k there, then 2 minus 1 we get 1 there. So then this will be equal to, we keep our k plus 1 the way it is like that there. So now here you find that our product there, so this is a quadratic expression that we have, so we can just simply try to factorize this here. So find that our product is 1 and our sum is 2 there. So meaning that if you multiply 1 times 1, it will give you 1. If you add 1 plus 1, it will give you this here. So here we're saying we're simply going to have k squared plus k plus k plus 1 being equal to k plus 1 this side here, squared like this. Okay, let me just scroll down a bit again. Okay, so now here The thing that is common between the first two terms here is k, so meaning that we can factor out k, we remain with k there plus 1, plus the term that is common on the last two terms that we have on the left hand side, this side is 1 there, so meaning we can factor out 1, open brackets, we have k plus 1 being equal to, this side we have k plus 1 squared like this here. So this and this here, when we add, we can group the terms there, so meaning that we're going to have k plus 1, open brackets, k plus 1 this side being equal to k plus 1 squared. So now, if you multiply a by a, it's going to give you a squared. So if you look at k plus 1 and k plus 1 here are just one and the same thing, so meaning that this side we're simply going to have k plus 1 squared being equal to k plus 1 squared like this here. So now, if you check this, we've shown to say that the left hand side here, the left hand side is equal to the right hand side as required there. So we've shown to say that if you add your s subscript k plus the new term a subscript k plus 1, it gives us the desired thing, which is the sk plus 1 term. So if this here is satisfied, or rather if this is proved there, then we can just go ahead and conclude to say that a given statement holds under mathematical induction. So here we're going to say therefore true for n equals to k plus 1. So since the first three steps that we have there, they all hold for the given conditions that we're looking at there, so we can just say this implies that the statement holds under mathematical induction for all n greater than or equal to 1 like this. Okay, so let's do a few more examples. So let me just erase everything that we have here. Then we'll look at a new example there. Okay. So the next example here is a bit different from what we did earlier on. So let's say example here. So prove that the summation. So we start from 1, then we go all the way up to n there. So let me, okay. So the summation of the expression that we have here, 4r minus 6 equal to 2n open brackets n minus 2 here for all okay. So where n is a positive integer there. So if you look at this example, it's a little bit different from the first example that we started with there. So meaning that here we're not given the terms here, so meaning that we have to make the terms on the left hand side together there. So meaning that here, this just tells us to say that r here is going to assume values starting from 1 all the way up to n, because we don't know what n is. So here we can just say therefore r here will assume values, let's say 1, 2, 3 there, all the way up to n like this, so that we have an expression that we're going to work with to prove this problem that we have. So now, when r is equals to 1 here, so let's find the terms. So when r is equals to 1, we're simply going to have 4 multiplied by 1 minus 6 here. So 4 multiplied by 1 minus 6, it will give us negative 2 there. Okay, so then here we check for the next term when r is equals to 2 there. So when r is equals to 2, we're simply going to have 4 multiplied by 2 minus 6, so that will be 8 minus 6. That's going to give us 2 there. So let's also check for when r is equals to 3. So when r is equals to 3 there, we're simply going to have 4 multiplied by 3, that's going to be 12. So minus 6, which will give us a 6 there. Okay, so we can work with the 3 terms that we have there. So meaning that on the left hand side, this side, we're simply going to have our negative 2 plus 2 there. Then the next term that we found here is plus 6. So we can just work with these 3 terms for the sake of time. So plus all the way up to, we said r we assume values up to n there. So plus, we say open brackets 4n minus 6 equal to 2 n there, open brackets, n minus 2 like this. Okay, so now we can go ahead now and start the proof because we have an expression that we can work with here. So now here, so let me just say proof there. Okay, so now step number 1. So as I said previously, I'm not going to write step number 1, step number 2. Instead, I just start with step number 1. I'll say this is step number 1, but don't try to say that's step number 1. So here, we're simply just going to start by saying we need to show that. We need to show that. Okay, let me erase that. Okay, so here we say we need to show that the statement is true for n equals to 1. So meaning that here we have to show that the left hand side and the right hand side will give us the same thing. So if that's the case, then we can conclude to say that what we have there is true. So now here we get the expression, so we just get this expression on the left hand side, then we equate it to this, then we make substitutions. Where there's n we put n, or where there's n we put a 1 there, and so meaning that there we have 4n minus 6 being equal to 2n here, open brackets, n minus 2 like this. Okay, so let me just scroll down a bit. Okay, so now when we make substitutions there, so 4 multiplied by 1 there, so 4 multiplied by 1 minus 6 being equal to 2 multiplied by 1, open brackets, 1 minus 2 there like this. So 4 multiplied by 1 there, that's going to be 4 minus 6, which will give us a 2 this side, then 1 minus 2 here, we'll get a negative 1 like this. So 4 multiplied by 4 minus 6, we're going to get a negative 2 being equal to 2 multiplied by negative 1, we get a negative 2 there. So what we have here, we've seen to say that the left hand side is equal to the right hand side, which is simply giving us negative 2 being equal to negative 2 there. So if this is the case here, we can just say therefore true for n equal to 1. So now after doing that, we go to the second step, which is the inductive hypothesis. So here we say inductive hypothesis there. So the inductive hypothesis. Okay, so here we make an assumption to say that this statement that we have is true when n is equals to k. So we say we assume that it's true for n equals to k. So this will give us the s subscript k term. Okay, so now here get the statement the way it is there on top. So we have negative 2 plus 2